Now naturally, you need to look at class videos to see solutions to a wider variety of problems than we can do in a last minute review. But let's solve, we've got 4 equations up here. Okay, this equation can be, now again, in class notes, in class videos, and this chalk is not writing very well. Here we go. We go through in a lot of detail how we solve these, but we divide both sides by 5. Okay, we can't subtract 5 because it's not 5 plus the exponential, so subtracting 5 won't get rid of the 5. We divide by 5, and then it's going to give us 5 times this divided by 5, which is just 1 times this, which is this. Very common error. I still see it quite a bit. Okay, now, using the fact that y equals b to the x means the same thing as log base b of y equals x, we can write log base e of 9/5 equals 3x plus 6. And then we can subtract 6 from both sides and divide both sides by 3 to get x equals 1/3 the natural log of 9/5 using the fact that log base e is the natural log minus 2. Because of course subtracting 6 from both sides gives us a negative 6 over here. When we divide by 3, we get the negative 2. I didn't leave myself quite enough room to do that comfortably, but there it is. Now I could have given myself more room here because there's plenty of room, but let's just kind of let this log thing spill over here. Okay, log base 3 of x squared minus 5 equals 2. The base is 3, so the base is 3, so the base of the exponential function would be 3. It's the log of x squared minus 5, so that would be here, and the 2 would be on the other side of the equal sign. So changing from this form to this, we find that yeah, 3 raised to the second power equals x squared minus 5. Something didn't look right, and it's just getting late, and I'm getting old. Okay, so we have this. So that's easily enough solved. 3 squared is 9, so we get 9 equals x squared minus 5, so that x squared equals 9 plus 5, adding 5 to both sides, that's 14. So x is the square root of 14. Plus or minus the square root of 14, and that's, in fact, that's so garbled, I'm just going to rewrite it. X equals plus or minus the square root of 14. Okay, this equation, well, let's see, we have 5x squared plus 30 equals 0, x cubed. We subtract 30 from both sides, we'll end up with this. Then divide both sides by 5, and we get x cubed equals negative 6. Then x cubed raised to the 1/3 power is negative 6 raised to the didn't come out very well, did it? Raised to the 1/3 power. X to the third to the 1/3 is x to the 3 times 1/3, which is x to the 1, which is just x. That's why we raised this to the 1/3. So that would be negative 6 raised to the 1/3 power. And what is negative 6 raised to the 1/3 power? Probably about 1.7, 2.89. No, it's going to be more than that. 1.8, 3.24. Somewhere between 1.7, around 1.8. Let's just say that's maybe around negative 1.8. And you don't have to do that mentally. You can go ahead and punch it in. It's a little more than 1.8, I think. I'm going to guess 1.83 maybe, something like that. See how I did. Okay, quadratic function. Well, this is a quadratic equation. You recognize it as quadratic because you know that if we put everything on one side, it's going to have the form of a quadratic equal to 0. So we do that, x squared. We're going to subtract 2x from both sides. We'll get a plus 5x. And then we're going to add 3 to both sides. That'll give us minus 6 equals 0. Okay? And I think coincidentally, that actually happens to factor. It's x plus 6 multiplied by x minus 1 equals 0. So x plus 6 equals 0, or x minus 1 equals 0. Because naturally, if the product of these two factors is 0, that means one of the factors has to be 0. And they can't both be 0 for the same value of x, so there are two possible solutions. And we get x equals negative 6, or x equals 1. Now, I didn't actually plan it so that this thing would be factorable, but I used fairly small numbers, so it wasn't impossible that that would come about. The quadratic formula. Okay, you would get x equals negative 5 plus or minus the square root of 25 plus 24 over 2 times 1. Just plug in 1 in for A here, and 5 for B, both places, and 6 for C. Just plugging it in. These are the numbers that we get. And that equals negative 5 plus or minus 1 plus or minus 7, 1, divided by 2. 7 because 25 and 24 is 49, and the square root of 49 is 7. Didn't have room to write it all out, but you can write it out and verify that. Well, negative 5 plus 7 is 2. You divide that by 2, and you get 1. Negative 5 minus 7 is negative 12. You divide that by 2, you get negative 6. So the quadratic formula gives you exactly the same thing factoring would. And of course, it has to be that way. Matter of fact, well, the quadratic formula is easily shown to be totally consistent with factoring. So, just a little bit about equations and exponential, power, polynomial, quadratic, and linear functions. And we've kind of implicitly included logarithmic functions in the mix.